Oh yeah, been shopping again. My son wanted a Noco booster for his car, so I came across this one, the GBX155. I paid £97 for it. I'm sure they retail at a couple of £100. Quickly see what this says. Power's on, flashes quickly before turning back off. Plug the charger in, looks like it's charging, but after a couple of hours it's still not gone up higher on the lights, and they would test further. Okay, so have a look at it, and this weighs a ton. There we go, GBX 155. Let's get this out. We've got no leads in there. Right, looks nice and clean. Got a little scratch there. Little dent in that cover there. Apart from that, it looks okay. So it's been used a couple of times, I can see that. I can see a few grubby paw prints. So this has been used, so it was working at one stage, so it's not like it's a custom return. Yeah, just normal use, I think. Right, so let's plug it in. Right, there's our USB in there. So it's a C charger. USB out, yeah, got two USB outs. 4,250 amps. Okay, got an override button, power button. Completely dead. Oh, we got a light. Nope, there's a light at that end. Oh, there we go. Right, so let's see what we got. We have USB-C in. Oh, it's got 5 inputs. A choice of. So you've got 5 volt 1.5 amp, 9 volt 3 amp, 12 volt 3 amp, 15 volt 3 amp, or 20 volt 3 amp. Right, so we can use 4 different types of charger. So obviously the higher the voltage and ampage, the quicker it's going to charge. Right, so if I use my switch charger, let me quickly grab it. Because this thing is 5 volt, 9 volt, 15 and 20. The 20 is 3 amp. Right, so this can, it will basically pull what it wants to pull. So if we plug this in, let's see if we get any lights at all. Nothing. The description did say the light comes on. So let's get a USB tester. So this is a C tester. It'll tell me what output we've got from this and going in. There we go. So we have 5.29 volts, but only 11 milliamps. You won't be able to see that there. I mean, I could leave this on charge for a bit, but I'd expect to at least see a light onto here. It's still on 11 milliamps. I know it's only been a few seconds. If only it's gone down 10 milliamps now. Yeah, it's fluctuating between that and 10. I haven't looked this up. I wonder if there's a sort of reset, but sync, sort of press and hold buttons. No. Yeah, it's 11 milliamps. That's not doing anything. So let's turn this off. Let's get this apart. and some soldered connections onto this thing. So let's unplug this first and we can get in there. Make sure there's no clips on the side. There we go. There's 1, 2, right, we've got a bit more room now. Alright, this one's glued on. Right, so there, obviously that's the battery. So we've got 2 reds, yellow, blue, green and 2 blacks. So is that 1, 2, 3, 4 cells? Right, it doesn't look swollen, which is a good thing. Let's see if we've got voltage coming out onto this battery. We'll see what we've got in the battery. So meter on DC voltage. Let's go red to black. We have 0 voltage. Red to yellow, no. Yellow blue, no. Blue green. So I think these would be cells. Red to that black. No, there's no voltage whatsoever into this. So let's plug it back in. Excuse me. Hay fever. So this is our power board here. Let's see if we get any voltage go into the battery at all. So you can assume it'd be the outside to be the complete voltage. We've got a negative reading, even though I'm red on red, black on black. So we've got negative 0.17. Let's turn this off. Let the caps discharge. No, that's a false reading. So we've got nothing coming into this, so I've just got to watch any caps that might be in this. I don't think there is. I think we need to get this board out. That's obviously just the light. Right, I think I need to use a bit of IPA on that glue. Let's get this plug off. Right, that's a case. Oh, visual checks. Look at that. So we've got a blown there. I can see another mark there. There's something else there. And everything else looks great. So let's line this up. Oh, I don't think we need to line it up. I've just looked and I can see a chip is blown. So that mark is there. That's over the board, so we should be in this area. Yep, and then that chip is there. Yeah, that's right where that blow mark is. So the only other one I'm going to be concerned about is down here somewhere. Right, I think we need to get this under the scope if I can. Really got to watch this light board because it's sort of just soldered on there. I'm going to get this under the scope and then I can look at desoldering these completely. Right, let me get set up and I'll bring you back in. Let's get rid of that. Right, I haven't desoldered the main board just yet because I want to look under there and see what's what and what we need to order. So let's go under this scope and let's have a look together. Oh wow, that's really lined up, that one. This was just randomly put under there. Right, so yes, I think it's safe to say that's a hole. Most definitely. From the tweezers. I don't need to move that, but yeah. It's actually blown. Look, I can get my tweezers underneath there. It's actually blew itself off the track. Wow. Right, so if this is marked up, is that Q16? Yeah, because that's Q4. Q17 is the one below. So Q's a transistor. So is this like a transistor package? Or some sort? Yeah, multiple transistors. Right, we've got Q4435. We've only got the 2 in this area. Q4435. Let me quickly look that up. Right, so quickly looked it up. This is a P-channel MOSFET. Okay, so it's definitely one of those. I'll have to look to see if 16, 17 are actually the same part. I'll find out. So the other one was down the end of the board. If I can move this board with the leads on it, it was down this end somewhere. I've seen a burn mark. I think it was sort of over here-ish. Let's see if we can focus that a bit better. Let's look for any burnt components. Aha! The power of looking at a case. Right, so it's whatever that is. Looks like 50B. That is definitely a hole. It could be. It could actually just be some coating, or where are we? No, I think that's safe to say that's a hole. Tweezers. Yeah, I can hear it scratching. Right, 50B. Now we're right next to the light, so is that like an LED driver? So is that one up here? Yes. Right, let's see if I can focus that a bit. Right, 8750B, 8750B. Let's go back to this one, which is up there. 8750B. Well, we're going to have to assume it's exactly the same. Yeah, that's marked as IC1. And we go back again. This one, IC2. Surely they're the same. So yeah, 8750B. 8750B. Let me quickly look that one up. Right, a bit of searching there, and it's coming up as a DC to DC step down regulator, a voltage supervisor, or a load switch, or a TVS diode. But because it's right next to the LEDs, like the end light there, it's going to be so obvious that it's some form of LED driver. So it's definitely gone. So let's have a look around the board and zoom that as much as I can on this camera. Some more LEDs there. I wonder if there's going to be another driver near these. Look for that sub 23.6 over here. No. that's the original blown IC. What is that fella? For IPA. Where are we there? That does look like a lump on that. I don't know where my tweezers gone. Like a lump on that chip. Where am I? There. Yeah, that's a crack. I'll get my tweezers into that. Right, so what's this one? Let's see if we can polarize this image. It's a bit better. So 1584EN or MPSS14. And some's a date code. Is that a 9? M9. Oh. It's getting more and more interesting. For a second. Let that evaporate for a second. It will. There it goes. Oh, I'm going to have to zoom down onto this. See if that's a 9 or a P. That's a P, isn't it? MP1584EN. Right, let's zoom back out. So S3778498. Right, that's the highest I can go. Just while I'm here then. See if that's the same sort of chip. There we go. Is that a hole as well? Well, it's definitely a P. And chips aren't supposed to have holes in them. Ah, it's just a bit of gunk, that one. Oh, that's alright. Let's put some IPA on just in case. Just make sure. I'm not sure about that. Is that a dot? So it doesn't have autofocus. You don't rely on me. No, that's a hole. Right there. Well, this is why we're recording this, because I'm not scratching the number off. That's a crack. Yeah, that's a hole. It is. Okay. Let's look them up there. There we can see. Yeah, that's definitely a hole, isn't it? Right. I'm going to pause you again and get my phone out and look up MP1584. We shouldn't need the EN. Right, carrot straight away. The MP1584EN is an ultra small 3A adjustable DC-DC step down, in other words a buck converter module. It accepts to 4.5 volts to 24 volt input and adjustable as 0.8 to 0.7. And it's 96% efficient. Well, I don't think that one is. I think that one's blown. And we'll just double check this lower one then. Yeah, it's definitely a crack. There's two. So it's 1, 2, 3, 4 chips, 4 ICs as such, or components. Right, so just thought, let me do some measurements because I'm not 100% sure if that is a crack or isn't. I'm going to order them anyway. I thought, let me just see if there's shorts around it, because we've got two exactly the same. We've got that one there which could be a scratch, and then we've got one further up that looks like a hole, but again I'm not 100% sure. So let me take you back to the desk, and then I'll just quickly show you under the meter under the scope what I'm going to do is I've got the pin out for this, and number 5 is the ground. So as long as we go to pin 5, then we can see on this one is that cap there. That cap there will be ground on 5, and it is. And then further down, this one we can see that is that side of that resistor rather is that ground, and we could probably use the battery ground anyway. So let me put you to the overhead camera. You might see a bit more, probably not. Let me get the scope out of the way. 1 second. Right, unfortunately you're not going to see too much, but what you can see is the reading on the meter. I need to test these whip voltages, but I'm just seeing if there was a short on either of those two chips. So basically if we go to ground here, which I know is the top right, which is pin 5. So if we go to, and if we go to this top 5, we can see we have 0.3, 0.2, 0.1 ohms. That is my leads. Let me do my leads. 0.1. Let's make sure they're pushed in fully and clean. Right, so if we go to pin 7, which is our voltage in, we have 429. So if we go to this one, 429, the same. So let's go any order really. Pin 8 is the bootstrap, so that's right next to it. So I'm getting 8 meg onto this one. Make sure I'm on it. 8 meg. So pin 6 is our frequency, and we've got 388 kilo ohms. 389 kilo ohms. Next is ground, which we know. So let's go around the circle. Pin 4 feedback. Our feedback gives us 32k, 33k. Down to this one. 32 rising. We're charging a cap there. 33k. Next one is the compensation. Pin 3. 9 meg and holding. 9.2 and holding. 9.2. Lovely. Number 2 is enable. 51k, 51.5k, 51.6k, down to this one, 51.6, lovely, and lastly is our pin 1 switch. Now this will be the one I want to test afterwards. It's 53k, there goes my meter. Let's finish this off. 53, 54, we're raising the cap. 55, is that going to be the same cap up here? Yeah, you can see it, we're charging a cap somewhere. 54, up to 55. Yeah, I'm happy with that. These are metering exactly the same, so unless they're both blown exactly in the same sort of way, I'm very tempted to fit a new chip onto here, see if it works. I don't think the LED is going to work, or half the LEDs are going to work and half won't, because we've got 2, 4, 6, 8, 10. So I'm going to assume that one chip does 5, the other chip does the other 5. So I think this would work, turn it on and only half will work. And we could change this chip and work, or is that a bad idea because it could surge to the other one? I'm not sure yet. I might do it just for experience, then see how it works, and if it doesn't, then we'll change these two. But I think I'm just going to order them anyway. It's just cheaper to buy extra components. You never know, I might come across One of these again. Right, let me get this in order and stop waffling on. Right, so 10 days later, these through customs, maybe because it's just in a small package. Then we've got our SOP 8. These are the replacement chips for the ICs that I think are cracked or blown. So the MP1584EN, that's them if I need them. So looking up the LED drivers, we've got a chip to replace that one there if needed. We have a transistor. Why have I bought these? I don't know. Oh, do you know what? I'm working on an e-scooter, so maybe therefore the e-scooter. I was thinking I never looked at the MOSFETs. Right, so that'd be an upcoming video. I assume they're for them. Oh, I didn't even know they got delivered. And then we had the Q4435, the one that's hanging off the board, and we've got ME4435. apparently it's exactly the same. So I was going to desolder this, but I'm more worried about this board breaking, and I'd have to desolder this. I'm thinking put it on, but obviously we've got our lithium battery. Now I do have a baker's mat here, which is a heat mat basically, and I was thinking, what if I use this to stop any heat going into the board? I can have this down here if it isn't too spongy. Maybe I don't need to fold it as much. Yeah, that would work. Saves me desoldering this. Obviously it won't take much, but I'd rather leave it if we have to. And it's literally just that one chip, test it, possibly these two if it doesn't charge, and then if the light doesn't work, then this other one. I did actually meter this one out, but I bought them anyway. So I think maybe we'll get under the scope and see if we can take this one out, clean the tracks, and solder back on the new one. Right, let me bring in the scope. Right, so we've got the scope set up, heat station's ready at 400 degrees, 60% airflow, and soldering iron at 350. Right, so let's get under there. So this is the chip we want to swap. That's the Q4435. We're going to fit the ME4435, exactly the same thing. So we'll start this hot air. It's going to heat up now. It's at 90 at the minute. So as it's heating, we're just going to warm this board. It's only a thin board, so we don't want all the heat into one area straight away. So find your tweezers. Here we go. We're basically just going to look for these pads that start to wet. They'll change colour. We should see the old flux in the board heat up as well. It looks like I'm a lot closer than what I am. What we don't want to do is pull that off. I'm going to put the airflow up a bit. There we go, we're at 65% there. Right, I think I've got 420. There's 420 there. It's quite a thin nozzle on this one. I can see that resistor over there starting to heat. This one up there. So this will be coming off fairly soon. You can always put some leaded solder onto this, because this is unleaded, so it's going to take a lot more heat to get off. Right, there she goes. Get that up without it disappearing. Right, so I'm going to repad this, sorry, reflow this with a bit of leaded solder. Okay, let's give that a quick clean. Oh, looks good. Okay, right, now while the board's still warm, let's get one of my chips out. Right, so before we put this on, because we couldn't see the old one, we've got to check the orientation of this. So if we see, you can see under there, yes. Can you just see where the groove is there? So that matches this one. And the pin 1, the dot is the bottom. So wherever the groove is, that's pin 1. So that there, pin 1, bottom left. So here, the groove's on this side, that means that that's pin 1. So we can't copy this, it's basically backwards. Let's find this chip. And the board is still warm there. Right, let's get this lined up. Right, here we go. We focused on. Let's see if I can do some polarization, make it clearer. Is that better? Yeah. Let's do heat. So we're at 420, 60 degrees, 60%. If it doesn't blow across the board. So we're looking for that just to wobble into place again. The board is still warm still. I'm still going to rotate round, and because this has got leaded solder now mixed in with the unleaded, it should flow in a lot quicker. We're just not holding that heat in one place. See, it's starting to wet now. The flux is starting to dry. There we go. Let's give it 5 more seconds. Lovely, that looks good. And I'm gently going to pull the heat away from the board, so I'm not just giving it some form of thermal shock. So we're at 420, 60% there. I'm going to let that cool just a little bit, because I'm going to put IPA on a hot board, and that should be cool enough. Now we put a bit on, you see how quickly that evaporates, and it's staying on there. So now we can give it a good clean, so it's a lot easier to clean while the flux is still warm. I do have some pads I need to do. I need to start using. Do you know what? Let me grab one, because I still haven't used them. And some IPA. These are little sponges, basically. I bought them. I've had them months. Maybe not sharp tweezers, because they push right into them. I'll just use my fingers. Use your fingers. Yeah, you can quite easily use your fingers on these. Not going to get your fingers in the way of the camera. That is a wrinkly. Right, let's just check these pins, because that one doesn't look the best. So I might add a bit of solder to that one. They're definitely soldered. I don't need to do the test on them. These are definitely soldered. It's just that one, which, give me a second. Yeah, it's on, but I'm not happy with it. So let's just reflow pin 4, which is that one there. So we're still on 350 on the iron. You see, it's still got the big tip onto it, but because it's at the end, we should be alright. Let me just quickly clean that tip. That's much better. A quick wipe. Find that little sponge again. Yeah, I think some blunt tweezers and we'll be alright. Right, that's definitely better. Should we give it a go and then worry about the LCD driver and them 2 chips? I mean, official switch chargers that goes 3512. So off at the minute. So this is our C in. So at the moment it's saying 5 volts. I haven't even got it switched on yet. It reckons it's got 5 volts. So I wonder if they're still charging. Hang on, it's actually pulling a charge. It's switched off. It's what's left in that charger. Oh, here we go. Right, let's turn it on. It's pulling 5 volts, 13 milliamps. So it was 11 before, 11 milliamps, but we still don't get any charge. 110. So I think maybe them 2 chips are gone then. Yeah, we get no lights at all. Right, just as well, I bought 5 of those. They're P-channel MOSFETs. So basically, the one I've just fitted, so we're far away. If I zoom in too much, you can't see this camera, and I haven't got the other one set up. So that's pin 1 is the, in this case, top right hand corner. So pin 1, 2 and 3. 1, 2, 3 is the source pin. Pin 4 is the gate, which is that N1 there, and the top rows are the drain. So if we go to pin 1 and 2, we should see a dead short, which we do, and pin 3, because they're all connected. And to the gate, we have 0.25, so we reverse our leads, 1 to 2, just to make sure we're on a connection on 1, and we have our 1.9. It's open. So we have source to drain, 0.3. There we go. Source to drain, 0.5, that's a diode junction there. 0.4, sorry, 0.4. Should be on all of those. And then our gate, that's our 0.9. And there it is, 0.3. Now the original one that was below, the pin is on this side. So this is pin 1. So we should have 1, 2 connected together, pin 3 connected together. Pin 4 should be our gate, so we should get 1.9. We've got a dead short. So even if I reverse my leads, we've got a dead short. So if we go gate to drain, dead short, and gate to source, dead short. That one's short with that. Well, we need to take this off the board and see if the short's elsewhere, because when I meted these chips out, there was no short set from them. So there's a good chance that this MOSFET blew and blew this one. It's just that took the brunt, and that maybe we need to take a closer look, see if we can see any scratches or blow holes in this. So right, back under the microscope. fun and games. Right, got this set up just to test these P-channel MOSFETs. So, safe to say, there's the original. Safe to say that that one has blown. So let's get rid of that. This is just some double-sided tape. It's just to hold it still. It's not perfect, but it will do. So you see in the top right-hand corner, the meters on diode test. It actually needs some new batteries into that. So we have these 4 pins here are the drain, these 3 here are the source, and then that's the gate. So basically if we go diode mode, red probe, as you can see there, to the drain, and we go black to one of these sources, make sure I'm on it, there we go, we've got a diode junction, 0.5 volt drop. Okay, if I can, yeah, rest it on that one, 0.5. Now if we put the black probe on the gate, we should have an open line. Make sure we're on it, we do. Then when we go back to the source, we should have a dead short. So that's it basically, that's that MOSFET is turned on. And then to turn it off, all we've got to do is put our red lead onto the gate, and go back, and we'll be back to a diode reading, which is correct. Yeah, then we could turn it on again. There's our short. Normally you can just use your finger. There we go, we're back to diode, because basically your finger is just shorting these two together, and it's discharging or opening up that MOSFET. There we go, back to diode, turn it on, there's our short, turn it off, back to diode. So that's how you test an N-channel MOSFET. So let's get the board under the microscope. Now we've got the meter set up. 1 second. Right, so this is the board back under. This is the one that just soldered in, the ME4435. As you can see, the original, I assume, was the G4435. Exactly the same chip. So as before, red to drain, black to source. We've got a diode junction. It's showing this because it's on the board. Okay, and so if we go from drain to gate to try to turn it on, we have our 0.9. So we've got resistance on this board because that should read open. And back, we've got a diode junction. So it's not turning on, but there's a chance it's it won't because of the board other components. So technically that should turn it off. So we're reading 2.4, and then back on. That's a diode. So even if we was to try and short this out, diode, turn it on, we could leave it on for a little bit, and it's not going to turn on. See, it's still turned off that moment. So let's test the other original, even though there's not. Oh, there is. Good. See it right there. A tiny little hole. Oh, good. I was thinking I couldn't see anything. So this is the right way up. So we go red to drain, black to source. We should see a diode, and we've got a dead short. Okay, and then all we do is put our black onto drain, so that should turn it on. That's a dead, and here be on. I mean, we could try shorten it with our finger to reset it, and the proper way to reset it would be to put the red on the gate, short, and short. You know what, I never seen that literally till now, that little hole there. That is, my probe is clicking into that. Oh, good. So I was thinking, oh, there's something wrong with the board now. Right, so just as well we bought 5. Right, we're ready to plug it in. We've got the same charger on with the tester. I'm really hoping to see some lights here. Make sure I don't touch anything. Let's plug this in, hopefully it doesn't go bang. 5 volts, no amp draw whatsoever this time. That's not good. Oh, here we go, 13 milliamps. It's the same. Just thought what I didn't do was test this. I will put it on a microscope, but just want to show you how small it is. There's my thumb. Right, so you can see the meter up, still on diode mode. So red to drain and get onto it. Back to source, and we've got a dead short. Back to gate, dead short. And then source to gate, dead short. It's completely shorted this thing yet. So yeah, I think it's fair to say that that is all the back of it. Yeah, I'll do a close-up picture of this afterwards. I can see the back of this tiny little chip. If I don't lose it, it's ballooned up. There's no way you're going to see it on the camera. Oh, maybe you do. Yeah, there you go, you can see it there. It's actually exploded downwards rather than upwards that most of them do. Anyway, and onwards upwards, as they say. Right, so back on the desk, let's give this a test. So basically we changed these 2 MOSFETs. I'm just thinking these 2 buck converters are right next to the 2 USBs. So I think if this starts working, it will just be those either won't work and we can change them. That's what I think there for that. And then obviously we know about the LED driver. So let's plug this in. But I have my voltages going into it. I'm going to leave it off just for a little bit and bring you right back in, hopefully. Well, I had this on for 15-20 minutes or so. We're still only pulling 10 milliamps, but we do now have a white light and a green LED. So, not sure what that one's supposed to be. I think that's the end one. I'm not sure. The white light is obviously power. Well, it depends where this board should seat correctly. Oh, because if the end one's there, it's like, is that full? Well, that's not right. Anyway, it seems to be doing something, and then it's not pulling current again. Right, this was literally just 10 minutes later. I left it on, and we have a flashing light now. There is the white light there as well. So we're on volts DC, and we have through the conformal coating, we have 5.169. Oh, it's shooting up, look. 113, 114, 115. It's slow, but there we go. Is that definitely flashing? Yes. Oh, minus, so I've got them backwards. Not that it matters. There we go, we get the 120, that'll do. It'll probably take a good few hours to charge this one. And we'll probably get to power cycle it to try and get as high as we can. Use it, or maybe just leave the lights on. All the lights even might work. Leave them on, let it drain down to it cuts off, so it's safe level, then fully charge it again. So similar to what we've done with the Jackery. Right, so let me leave this alone, and I'll see you again soon. It's actually working, fully charged. Well, I'm injecting 15.8 volts into it. The USB works, the LEDs work. That power regulator, that one down there, that one there has blown, so we're missing a couple of LEDs. So it basically, we have two P-channel MOSFETs were blown, and it was down to, that's the power bank there. It weren't till I had a look. This one's blown and this one's blown. They're supposed to lose their charge 1 to 3% in a month. This was losing in 10 seconds. So that's the actual power bank there. They're like £18 a battery. So I might order up some batteries to replace this. So it looks like the actual battery pack has gone. I charged it and injected it. I've got the batteries up to 5 volts each, but they drained in seconds, literally. So it wasn't holding a charge. So the BMS, the battery management system, onto this wasn't recognising it, didn't like it, and kept jumping from 25% up to fully charged in a matter of seconds. So I thought I'd order up 4 new cells, make their own battery pack, battery bank as it were. So we're talking sort of £72, and then we need a battery welder. So I had a quick look on eBay, and someone was selling one for £100. Working, but the boost function didn't work. So hopefully I can take the battery pack out of that. I'll have spare parts, and more importantly, from 2 I'll get 1 working. So in all, this will probably cost me about £200, but they retail for about 400. I think I've seen one on Amazon for 300. I'm not sure if it was a real or a fake one, but regardless, I'm doing this for fun, really. I'm not doing it for content as such. Of course I want to make videos, but I'm doing it for fun. So I'll be back soon as I get it. Thanks for watching.